All right, welcome back to statistics. We are going to probably finish off our test of hypothesis with sigma known section today. So let's go right ahead to it and share the screen and start working on some stuff here. So if you are actually in one of my classes, I just want you to know that actually I have used this problem on an exam before. Okay, it's not my favorite problem, but when I'm desperate looking for something, this is an example of what I would use. Okay, it's just enough to like test with, see whether or not you know what you're doing, but not hard enough that it's a major problem. So that was an easy, I need an easy to medium level question for you to solve. Okay. Excuse me. So are you smarter than a second grader? You have a random sample of 57 second graders in a certain school district given a standardized mathematics skill test. Mean score is X bar equals 46. Assume the standard deviation of the test is sigma is equal to 15. Nationwide average on this test is 50. School superintendent wants to know if the second graders in her public school district have weaker math skills than the national average. Use alpha equals 0.05. Okay, and we'll just use the calculator for that. But first, what we're going to do is just going to walk through the idea here. Okay, so first, we're going to set up our hypothesis. HO, HA. So we have these second graders taking some kind of a standardized test. I'm sure they take plenty of them. And then we're going to have a mean score of 46. The nationwide average is 50. So they want to know, is it 50 or does the superintendent have to worry about anything? Okay, so she's not worried that it's greater than, she's worried that it's less than. Okay, that's good. They want to know, like, are our students performing up to par with everybody else? Okay, so it's either 50 or it is less than 50. All right, that's what she's worried about. Our level of significance, okay, is going to be 0.05. All right, that's our second thing. 3, we're going to calculate our test statistic. Or rather, the calculator is going to calculate our test statistic, but let's write down the pertinent information that we're going to need here. Okay, we need, what is our X bar? Our X bar was 47, I believe. What's our N? Okay, so still related to central limit theorem. What is our N? Our N is, let's see, not 46, 57. What's the standard deviation? Okay, standard deviation on this test is going to be 15, I believe. There it is, 15. Okay, so let's run off to the calculator and see what happens. Okay, so we are going to stats. We're going to do a test, the z-test in this section. Again, we're just giving it statistics. We don't have a long list of numbers to put in, thankfully. Okay. Mu, right? The national average is 50. Our standard deviation is going to be 15. Okay. X bar was 47. Okay. And is going to be 57. I don't think there's going to be a difference. And again, they want to know, is it less than? Do we have something to worry about? Okay, are our students performing to the national average or not? Okay, and then enter our spots. Okay, so what do we have here? We have z is equal to negative point. This is our test statistic here. Z is equal to negative 1.51. Let me go make it. Okay, our p-value. Okay, our p-value is 0.0655. It's right there. Okay, 0.0655. Now we have to compare, right? As our p-value 0.0655, a bigger or smaller number than our alpha 0.05. Okay, it's a little bit bigger than it. We said, well, this is the level we're going to say there's something unusual going on. Maybe we need to look for an alternative solution. But since it's not smaller than that, we're going to say, well, since our p-value isn't extremely rare, right? Rare being 0.05, so that's the level we chose. We're going to say do not reject HO. Okay, what this means is the school's second graders, our second graders, are performing good Lord to national standards. You can't say that these kids are any less than national standards. Okay, it's like, but the averages, like, yeah, well, once you take into account the standard deviation, that you only have a sample of kids, we're not, you know, there's not enough of a difference. Okay, that's what we're saying. All right, state the null hypothesis. Okay, mu is equal to 50. I'm going to say mu is less than 50. Okay. Looking at these numbers now, kind of wondering, like, did I put the right ones in? 47. No, I didn't. This is a 46. I should probably change that before we go on. Okay, I'm so sorry. I did not type the things into the calculator correctly. Okay. We wanted 46. What else did we want? 57. The school district has a 0.50. Okay, standard deviation, we're good. 57 kids, we're good. Let's go ahead and calculate, because that's going to change things. So let's correct that error before the computer has to correct it for us. Ah, there we go. Wow, that just, all right, well, we're going to change our conclusion because we got a different test statistic. Okay, I'm sorry that I misled you. Okay, so here we go. Z is equal to negative 2.013. P is equal to 0.0220 rather. Okay, alpha was 0.05. Okay, and then everything else is the same. Okay, so there's our new and improved test statistics. But look at this. P is now 0.0220. Okay, P is now, so our 0.0220, this is less than 0.05. This now does qualify as being unusual. Okay, so we're just going to go ahead and say, because p-value is less than alpha, right, less than our standard, we do reject HO. Our kids are doing poor. Okay, reject HO. So our conclusion is here, yes, our second graders are underperforming compared to national average. Okay, there might be a lot of reasons why that's happening, but clearly they're not doing as well as the national averages. So we're going to have to do something about that. Okay. So hypothesis test is again, it's the left hand side because we're worried about the lower part. We're not worried about the upper part so much. If they're performing better, then so be it. That's great. All right. Consider the p-value statistic. The p-value was 0.220, I believe, or what was it? 0.0220. Okay, we're good. Check my answer. All right, happy with that. Okay, again, this was less than alpha. We are going to reject the null hypothesis. Okay. And then we're going to say there is enough evidence. There is enough evidence to conclude that the second graders in the superintendent school district have, I would not want to say it this way, but less math skills than the national average. Okay. And yes, you have to write something. Okay. You can't just write reject HO and go to the next answer. Okay. The next question. You have to say, explain it to whomever is reading it after you get done with it. Okay. So that's what I had to do when I took this class. It's what you're going to do when you take this class. Okay. You gotta do that. Okay. Next. Okay. Older men shorter than younger men. Okay. According to a national report, the mean height for U.S. men is 69.4 inches. Okay. 5'9", 0.4. In a sample of 302 302 men ages between 60 and 69, the average height was 69.1 inches. Public officials want to determine the mean height for older men is less than the mean height for all men. So let's go ahead and figure that out. All right, so again, there we go. Let's go through our steps. First step is we are going to write down, this is our hypothesis, okay? 1, HO, H1. Okay, your book uses 1, so I'll try to comply. Okay, so the average height, okay, where are we going with this? The mean height for, I want a mu. Okay, right at the top here. National report, the mean height for U.S. men is 69.4 inches. So mu is equal to 69.4. Okay. And they say public health officials want to determine if the mean height for older men is less than, which side is that? Mu is less than 69.4. Okay. What alpha did they want? They wanted alpha equals 0.01. This was step 2. Step 1, we set up our hypothesis. Step 2, we declare our alpha. Step 3, we're going to go ahead and calculate our test statistic. Okay, it's going to be a z statistic because the standard deviation is known. So we're going to say, okay, that's nice. We have sigma is equal to, what is our sigma? 2.79. Okay, our X bar was our average, our sample average. Our sample average looks like X bar is 69.1. What is our sample size? It was 302. Okay, and I think that gives us enough information to start working here. All right. So let's go to our calculator because that's, next thing we're going to do is calculator. All right. So we're going to hit statistics and then tests because we're doing hypothesis tests. Test. Okay, it's a z test. So I guess I click that automatically somehow. Again, we're not punching into numbers, so we go to stats. Our mu is 69.4. Okay, that's what we set up here. Okay, our standard deviation was 2.79. Our X bar was 69.1. Okay. How many people do we have in the study? We had 300. They're not going to like that. We have 302 people in our study. And again, they want to know about less than, so that's the appropriate piece. Okay. And then calculate. Okay. So here we are. So that's our step 3 or step 4. Okay. What's our p-value? I don't want that. What's our p-value? 0.030. It looks like an 8 there. 0.0308. Okay. And our alpha was 0.01. Which one's bigger? Okay. Which one is bigger? This is 3 pennies. It's 1 penny. P-value over here is bigger. So we set our cutoff for noticing a difference is 0.01. We only got down to 0.03. We did not notice a difference. Okay, so we're going to say p-value is larger than alpha, so we do not reject the null hypothesis. Step 5, what does this mean? It means that older men are not shorter than younger. When I say older, what sample did they get? They got 60 to 69, didn't they? Okay, they got 60 to 69 people. So well, there might be some bone loss, right? And this might be a thing for some. Apparently, it does not take place in your 60s. I'm still safe. Like height's a big deal. All right. But we're not going to care about that yet. Okay. So let's go ahead and fill out the problem on the book. Okay. Oops, I don't want that. I want just this right here. Okay. So null hypothesis. Mu is equal to 69.4, or the alternative, mu is less than 69.4. Okay. So again, the logic we're using, we're not trying to prove anybody right. We're just trying to prove this person wrong. Okay. That's all. And we couldn't do it. So again, left-tailed because, right, we're worried about people shrinking in height. Okay. Check answer. Okay. Compute the p-value. What was our p-value? P-value was 0.0308. 0.0308. By the way, when I ask you this on a quiz, like you're kind of on your own to put all of this together. Okay. So we are going to say, do not reject the null hypothesis. Okay, because we had 0.03 and our standard was 0.01. We were not less likely than our standard. Okay, so by random chance. Okay, there is not enough. This you don't have to write formally. Okay, if you're worried about like what to memorize, like memorize is 5 steps. Okay, and then worry about interpreting what's going on. But I'm not going to expect you guys to write like this. Okay, there's not enough evidence to conclude that the mean height for older men is less than the height for all adult men. And there we go. All right, excellent. All right, not doing too bad. Hold on a second. This is effectively the same problem that we just did. I wish I had skipped it, went to this one instead. So I'm taking a little piece here. Okay, we'll definitely do number 9. Okay, we're going to do 7 because I've asked this one before as well. Okay, I've asked this one before. So it says one of the measurements used to determine the health of a person's lungs is the amount of air that a person can exhale under force in 1 second. This is called the forced expiratory volume in 1 second, abbreviated FEV1. Okay. The average FEV1 for 10-year-old boys is 2.1 liters. I'm sure they delighted in taking this test. Here, blow up a balloon. 1 second. And the population standard deviation is 0.4. Random sample of 63-year-old boys who live in a community with high levels of ozone population, or pollution rather, are found to have a sample mean of 1.97 liters. Can you conclude that the mean FEV1 in the high pollution community is less than 2.1? Okay. The reason I like this is because it's a good problem. It fits with the example I keep in my head for like why is, how to remember which one is which. Okay. So there we go. All right. So first step, what is our test of hypothesis? HO, H1. Okay. So you can just imagine where whoever's polluting this area is like, nah, they're the same. They'll be fine. Okay, we're not paying for anything. We want 2.1. So we're going to test if whether or not these boys are 2.1. Okay. What we're concerned about is that it's less than 2.1 because that means they have weaker lungs. Okay. Now, our alpha is equal to, what is our alpha equal to? 0.10. Okay. Okay. And there we go. Okay. There's our second step. Third step, calculate test statistic. Calculate the test statistic. So again, it's going to be a z test It's one-sided, it's to the left. Okay. If it's ever this side, if it's like that, then it's going to be to the right. So you might be testing whether or not there's more arsenic in your drinking water. Okay. And the things that we're going to need an X bar. Okay, so I need an X bar. So that was 1.97. We're going to need an N. Right, our N is going to be 63. We're going to have a sigma. Sigma is known because it's a z-test. Okay, so sigma was 0.4. Okay, and then we're going to go to calculator. Okay, so going to the calculator, we're going to go to stat. We're going to turn it on. We're going to go to stat. Z-test, there we go. And we're going to still do some statistics. Our average, right? What was our average? Our average was 2.1. Okay. Standard deviation was 0.4. Okay. X bar, average that we have here is 1.97. Okay. How do we have here? We had 63. Okay. And I think we're good. We're looking at the left-hand side. Okay, and then we're just going to calculate. All right, so our Z was equal to negative 2.58. Okay, negative 2.58. Okay, p-value was 0.0049. Okay, so this was p-value 0.0049. Okay, what was our alpha? Our alpha was 0.10. Okay, so we're going to have our p-value of 0.0049, and our alpha is 0.10. And even if you were doing this for, maybe you were doing this for, you were hired as a consultant for the companies that are suspected of polluting in this area. Your boss says, well, couldn't we? Like, you could, but I'll tell you that you'll know what the courts usually admit as like a reasonable p-value or a reasonable alpha, and it's usually 0.05, but something you would look up. So tell somebody, like, look, this is pretty overwhelming evidence. Okay, p-value less than alpha. Like, settle now before they take you to court, because it's going to look bad and you're going to lose because of this. Okay. So if you're on the company side. If you're on the community side, you're going to say, you got a pretty good case here. Okay. So you even went to 0.10 rather than 0.05. Okay, so p-value is less than alpha. We're going to say this definitely is less probable than your standard was. Okay, so it's not by random chance. We need to seek an alternative explanation. So we're going to say reject HO. Okay, there is significant evidence to show that the FEV1 values for 10-year-old boys in this neighborhood is lower than average. Okay, so the boys have a lower FEV1. Now, you wouldn't say this you wouldn't write this in a scientific paper, because you don't say that. You just say there is evidence to suggest that this is true. Okay, but if you had to explain this to somebody, they're like, yeah, that's pretty bad. Okay, so we'll go back here. Okay, and again, all the 5 steps were done. So mu is equal to, what do they want? They wanted 2.1. Okay, 2.1. And an alternative hypothesis is mu is less than 2.1. Okay. hypothesis test is a left-sided tail. I generally don't bother asking you for this. Okay, I just want you to tell me, like, what is your alpha? So we went through, we did this. Okay, so I don't quite align with the book there, and I apologize for that. But our p-value was 0.0049. 0.0049. Determine whether or not to reject it. Reject the null hypothesis. Okay. And we are going to say there is enough evidence to conclude that the mean FEV is less than, that's all you can say. Okay. So there we go. All right. So again, I know that I have asked this question on a quiz before. It's a medical thing, so it's like automatically there. Besides, it, you know, feeds into my little analogy about love canal. So it's definitely a good choice for me to pick. All right, not going to look at number 8 because number 8 looks a lot like the problems we just finished. Okay, when they say 1,000, understand that the mean that they want is 260.7 and then $1,000. Okay, so just move the units, so we're dealing with 260.7. You don't need to add an extra 3 over here. Okay, and we'll do number 9. Okay, so this is a little bit different. Okay. So we have mean GPA under a certain university is 3.46. The GPA is from a random 20 business students from the university. Boom. One of the things you have to do is decide whether or not the data is relatively normal. There are tools to do this. They do not provide you any of those tools for you to say so. So all you can do is look at it and say, I guess so. I will not ask you a question where you have to verify this. Okay, so we're going to say, sure, it's relatively normal. Okay, I mean, you're not, this is a little skewed. So if they come out with an opposite answer, I'm not unwilling to believe them. Okay, I'd like to see this line toward the center so it's a more symmetric distribution. Okay, but that's what this is telling me. It's not exactly symmetric. Okay, the histogram would have a long tail in the left-hand side, not so much on the right-hand side. If I was going to attempt to sketch a drawing, you know, it would look something like this. Okay, which you could definitely suggest or make the case that it is not relatively normal. Okay, I'm just going to make the statement, you could assume it's relatively normal. Why do we care? Well, I'm going to say that it's reasonable. Okay, we'll see. Okay, they let us go with that. Why do we care? Well, you remember the last couple of problems, all the n's were bigger than 30. So the central limit theorem applies and says that since the sample size is bigger than 30, then X bar is a normal distribution. Here we don't have bigger than 30, we got 20. Okay, so we have to check to see if it's normal so that X bar will be normal. Okay, so we still have to follow that rule we learned in chapter 7. All right. So, and I used to have a teacher that would bluff us. You know, we'd have a 4-question like midterm, not a quiz, but I mean there'd be like 3 tests, 2 tests, and there'd be 5 questions on it. One of them would be something like this, like, no, it's not reasonable to assume that. Like, what? And if you ask me 5 questions and one of them I'm not supposed to answer. Yep, that's how it works. I am not doing this to you. Okay, if I ask you a question, I expect an answer. If I'm going to ask you something like this, it's going to be a multiple choice thing with like A, B, C, and D to decide, is it reasonable, is it not reasonable? Okay, but again, there are other statistical tests that you'll learn in other classes to see whether or not something is normal. I would trust that more than I would trust my eyeballs to say, it looks about right. No, there's a test to do it. We're not doing this. Okay. So let's go back up to the beginning. Okay, look at our little thing here. Did they not ask me a question about this yet? They didn't. All right, whatever. So we're going to assume that the standard deviation is sigma equals 0.5. perform a test hypothesis at the point, let me move me out of the way. Okay, at the 0.01 level. Okay, to determine whether or not the GPA for business students is less than the average for the whole university. Okay, so let's go ahead and put this together. This would actually not be a problem either. This would be the medium to hard side of things, where the other two problems were the medium easy side of things. Okay, they still count as medium problems because there's a lot you have to put together. Okay, but that last problem we did was medium, little easy. This one would be medium, a little hard because there's a couple more steps. Okay, HO. Right. The average is the same as the GPA as everything else. Did they tell us what the GPA was? No. 3.46, very good. HA, okay, we are worried that these business students is less than. I would have liked at least one, not the same as. Thanks. Okay, what is our alpha? Our alpha is equal to 0.01. Okay, so that's our step 1. That's our step 2. Step 3, calculate our test statistic. Okay. I don't really care if you label the steps or not. That is not something that's going to be on you. Okay. So we have a left-sided test. We have a X bar. Well, actually, we have a lot of points for X bars. We have a whole bunch of data here. Okay. So we're going to go ahead. I'm just going to write down C data. Because the calculator is going to handle that for us. Standard deviation, population standard deviation was 0.5, right? 0.5. I think the calculator will automatically do this, but n is going to be 20. Okay. So what we're going to do, because they gave us the list of numbers, we're going to use them. Okay. So we're going to go to stat. Actually, I'm going to go ahead and clear list 1 here, just to make room for it. Okay. So we're going to go back to stat. We're going to edit a list. Okay. We're going to edit this list. Okay. And we are just going to type these things into the calculator. Okay, so here we go. 2.19. Okay. 2.99. 2.56. 2.41. 2.99. 3.61. 3.21. 3.49. 3.39. 3.88. 3.55, 3.63, 3.75, 3.01, 3.65, 3.09, 09. There we go. 2.24, 3.29, 3.29. Doesn't matter which order they're in. So we got the 2.24 and the 3.29. We need 2.85 and 3.65. And I've entered in 20 numbers. That's how many they said there were. So we can kind of go up and check, just to double check it. All right, 2.99, 2.56, 2.56. What was that? It was 3.39. We had a 3. That is a 3.88. Okay, 3.55. Okay, 3.63, 75, 01, 65, 09, T24, 3.29, 285, 365. Beautiful. All right, next. Stat. Test, z-test. Okay, here we're going to change. Go to data. Okay, we're going to data. What's our our mu, right? What is our standard that we're trying to have to deal with here? 3.46. Okay, here it is. It's 3, no, not 6. 3.46. Okay, our standard deviation was 0.5, 0.5. Okay, our list is an A1 or L1, beautiful. We're not going to worry about frequencies. Okay, and again, they wanted to know left-hand side. Okay, they wanted to know if it's less than. Fine. Oops. Nope, get rid of this. What am I doing? Stat, back to tests. Sorry, I misclicked that. Everything else should be just fine because we didn't mess with it. Calculate. And there we go. Okay. What is our test statistic? Our test statistic is negative 2.58. Okay. So our fourth value here is equals negative 2.58, meaning our p-value is 0.0049. All right. X bar was 3.17. Okay. So we have our p-value, 0.0049. We have our alpha value, 0.01. Which one of these is bigger? Alpha is bigger. Okay. So by random chance, right? We expected that by random chance you could have gotten a GPA this low by, an average GPA this low, 0.01%. Okay. This is worse. Okay. So we're not going to say, oh, this is random chance. We're going to say, well, these 20 business students or business students have a lower GPA than the college in general. Okay. Again, I don't know what the reasons are. Not my, I don't know anything else other than what they told me. Okay. So we're going to say p-value smaller than alpha. Okay. So we're going to reject the null hypothesis. Again, we got a lower value here. Okay. So there must be some alternative explanation as to why this is so low, not just by random chance. Okay, so reject HO. What does this mean? This means students' GPA is lower than university average. Okay, that's what we were asked to look at. So let's have a look. Again, never asking you this question. Okay. Mu is equal to, no, mu equals, what was it, 3.4, 3.46. And mu is less than 3.46. Oops. There we go. Again, if I do that, it is a one-sided, a left-tailed test because, again, we care about smaller than. Okay, so we're going to check our answer. Right. P-value was 0.0046, I believe. 49. 49. All right. Reject HO. So we were rejecting the null hypothesis. Okay. And then, okay, there is enough evidence to conclude that the mean GPA for the business or for the business students is less than the GPA for the whole university. Okay. So there we go. So when you're studying these, if you need, like the first time you're doing these problems, if you need to look at some of the guide solutions, show an example of, et cetera, et cetera, et cetera, that's fine. When you're studying for your exams, okay, when you're studying for your quiz, you should be able to go through this without extra help, without asking any of these extra questions over here. If you're like, I'm going to do this problem, and you're like, oh, I'm stuck, show me an example. You don't know it yet, okay? You need to do 3 more problems like this, okay, in order to say whether or not you know it without asking for help. Okay, and 3 is my guideline because that's what worked for me. For you, it might be 2. For you, it might be 4. Okay, but as you're learning it for the first time and you're using them to check my examples, that's fine. But when you are rehearsing for a quiz, okay, and I don't mean study, I mean rehearse. It's an assessment you have to perform. Okay, so you have to rehearse. And you say, oh, let me check this. You don't know it. Okay. So when you get to the quiz, you're like, there is no show me an example button. Right. There is no show me an example button. If you thought you knew it, you were doing the show me example, you are allowing a false sense of security. Don't do this to yourself. Okay. I usually use it, or I usually use like if you were in a music program or if you were in theater, you're like, wait, let me check my notes for my line. Like when you have to go on stage and do that in front of an audience, you're screwed. If you're, wait, where are we in the music again? I'm still reading it. I don't have it memorized. You're screwed because you are going to lose your place. Like in marching band, you are going to be concentrating on, oh shoot, there's a little scuff on the field. I got to avoid that. I got to make sure that that the person doing their choreography, I stay out of their way. So I've got to navigate around all of that. If you have to look at music while you're doing it, you ain't gonna make it. So you have to memorize that kind of stuff. I'm not saying memorize every piece that we have here, but have like those 5 steps. I have a plan to do this problem, okay? And carry out the plan. And if you have to look for hints, you don't know it yet, you got to practice until you know it. All right. So just when you're prepping for your quizzes, and this is for all of your classes, when you're prepping for your quizzes, try to think to yourself, I have to do this in an environment where I am not going to be allowed to have extra stuff available. Okay, and that's going to help you do a bit better with that. The other thing is like, I don't really put a time limit on your exams, but some people do. Okay, and if you have a time limit, you should get a kitchen clock, one that ticks. Your grandmother probably has one. Okay, but get one that ticks, and so, well, I've got to do 4 problems. Let me see if I can get these 4 problems done in an hour. Let me see if I can get these 4 problems done in 30 minutes. Whatever the constraint's going to be for your class, and wind it up so it ticks, and do your quiz while it's ticking at you, because it's gonna have a stress because it's ticking. Okay, it's going to drive you nuts. But if you're having trouble with stress under pressure for taking exams, I'm not saying it's going to get better. I am saying you're going to get used to it. Okay, so try to study under the same environment as you're going through with your exams. Okay, I'll stop talking now. We'll hit 9.2 next time, or 9.3 rather. All right, have a good one.